Good part of the day, dear students. Now your question 2.12. I skipped like 2 or 3 questions since they are simply repeating questions. Now this is the last question of the seminar 2.12. We are in a Jacobian matrices in financial modeling. In a Jacobian matrices, we will be given simply to two matrices like the first two functions, sorry. Function 1 x squared plus y squared and function 2 xy. And we are given the values for x and y, 1 and 3. And how the Jacobian matrix looks like, it is simply the derivative of derivative from function 1 with respect to x and derivative from function 1 with respect to y, and derivative from function 2 with respect to x, and derivative from function 2 with respect to y. We are talking about partial derivatives. Okay, now, since we have the formula of the Jacobian matrix, let's find us each element of it. I should take the derivative from the function 1 with respect to x here. Okay, and it should be equal to my first function is x squared plus y squared. Okay, I have to take the derivative from x squared. It would be simply 2x. And if I take the derivative from the function 1 with respect to y, it should be simply 0. It will be plus 0. And then answer is simply 2x. 2x. With that logic, if I take the derivative from the function 1 with respect to y, it should be equal to, if I take the derivative from x squared, it would be 0 because I'm taking the derivative with respect to y. My variable is y. The x simply will be the constant, and then plus y squared is simply equal to 2y, which is equal to 2y again. Yes. Now, it is time to turn into our second function. I have to take a derivative from function 2, with respect to x again. Here is interesting thing. Okay, if I take the derivative from this 2xy, this y would be constant. And since this y is being multiplied to x, the simple answer would be 2y, but why it is being 2y, let me explain in that way. For example, okay, I can fit it here. I have 2x, y, and I have to take a derivative from this function with respect to x. But I first replace the terms of the function. I write like 2y multiplied by x. I can replace the positions of each term since I have the multiplication, and I have to take a derivative with respect to x. And why I did this is very simple. This 2y together will be my constant. This x would be my variable. For example, if I have here 2x, the derivative from 2x simply will be 2 itself. If it's 2yx, then simply the constant will remain as it is, like 2y. Then I have to take a derivative from function 2 uh, with respect to x. Sorry, with respect to y this time, which is equal to, with the same logic, it should be equal to 2x. Then I can continue this Jacobian matrix. The first term here is 2x. Then 1, 2 position is 2y from first function with respect to y, it is 2y. And then from the second function with respect to x, it's 2y again here. And finally, my 2 position element should be 2x, which is the derivative from function 2 with respect to y. Now, they are giving us the values for x and y, x equal to 1, y equal to 3. If we plug in what we get, 2 multiplied by x, which is 1, and here I have 2 multiplied by y, which is 3. Then I have here 2 multiplied by y, which is 3 again, and 2 multiplied by x, which is equal to 1. And the final Jacobian matrix should look like something like this. It's 2 here, 6 here, 6 here, and 2 here. That's it. This is my final answer for the Jacobian matrix. Thank you very much for watching. Stay tuned. More questions are coming.